Hello guys, welcome to the second unit of Module 5. In Module 5, we spoke about the types of drives. Gear drives, mechanical drives, and belt drives. So I'll focus on this unit of gear drives. The gears are used for transmission or for transmitting mechanical power from one part of a machine to another. For example, from one axle to another axle. There are so many practicals of the gear drives, such as the gearbox that are used in gearboxes, they are used in bicycles and mechanical watches. So we know that in bicycles, they're in combination with the chain drives in order to transmit this mechanical drive. So a bicycle has a gear at the same time it has the chain. So we have gear drives, belt drives, chain drives. There are 3 types of drives in Module 5. The gear drives, they have advantages and disadvantages. So the learning outcome, we're going to talk about advantages. We're going to focus on single gear system. We'll focus on compound gear system. Advantages of using gears. High power can be transferred. Slipping is eliminated as gears mesh with teeth. Direction of rotation can easily be changed by putting an idler gear. Gears mesh directly and losses are minimal. Gears need very little maintenance. Type of gears. We have a spare gear, helical gear, rack and pinion, a bevel gear, and a worm gear. An intermediate or the idler gear, the one that is used to change the direction. So if we have the 2 gears, which is gear A and B, in order to change the direction of B, you need to put the idler gear so that B can rotate in the same direction as the driver gear. Now, the purpose of this idler gear or the intermediate, it changes the direction of the driven gear. Without this gear C, A and B will rotate in opposite direction. Because when A is in mesh with B, okay, let's focus. If this one, the intermediate gear is not there, and A is rotating clockwise, B will rotate counterclockwise. But by introducing the intermediate gear, we are changing the driven gear so that it can rotate in the same direction as the driver gear A. Number 2, it allows the center distance of the driver and the driven to be varied. So in exam, you can be asked to give or what is the purpose of an intermediate or an idler gear. This is the purpose of this gear, this one. Now the formula, since the slip is minimal in gears, the velocity of this gear will be equal to this one, since this is in mesh with this, and also velocity of this one will be in this one. And the velocity is given by number of rotational or revolutions multiplied by number of teeth, equal to velocity of this one is also number of rotational frequency multiplied by number of teeth. So this velocity will be equal to this velocity. NB over TB is also velocity of the driven gear, which will be equal to C. So when you do calculations, if you are looking for the number of teeth for C, you're going to equate A and C if the A has the given. But if A has no given, there is also a relationship between C and B. So gears that are in mesh, they have a relationship. Also, the input has a relationship with the output gear. Because a velocity ratio, which is VR, is given as the effort distance. So effort will be the input divided by the output. So there will be a relationship between the input and output. A single gear system. A single gear system is a type of combination that has one driver and one driven. So if we have gear A and gear B, that is called the single gear system. So A will, if you give A clockwise rotation, B will rotate in the opposite direction. But if you want to change the direction of B, you can put an intermediate gear or an idler gear to change the direction of B. Because when this one is clockwise, this will go anti-clockwise and drive this one in clockwise direction. The formula of a single gear system, when you have two gears that are in mesh, is NATA, which is the velocity is the same. Number of teeth is T, and the A is the revolutions or number of revolution or rotational frequency. So NA is for the first gear, TA is the number of teeth of the same gear, equal to NB, rotational frequency of driven gear, multiplied by TB, number of teeth over of the second gear, which is the driven. Velocity ratio is effort over the load, effort distance over the load. So between the driver and the driven, the driver is the effort, because without putting a minimum force on the effort side, the driver side, this will never be driven. So it's the output. Velocity ratio is the driver over the driven. Also, you can calculate a velocity ratio using the number of teeth. Let's look at this. If you have NA over NB, NA multiplied by TA equal to NB multiplied by TB. If you make a ratio of rotational frequency to the ratio of number of teeth, this you're gonna divide by TA and NB both sides. So you divide both sides by NB times TA, both sides by NB times TA. Then TA cancels TA, this side NB cancels NB. So NA divided by NB is equal to TB divided by TA. So you can calculate a velocity ratio using rotational frequency or using the number of teeth. But when you are using the rotational frequency, the effort or the driver is the numerator, whereas a driven is the denominator. When we are using the teeth, number of teeth, driven is the numerator and the driver is the denominator. When you cross multiply, it's still giving you that one. Cross multiply is giving you this one. So you have two formulas to calculate velocity ratio. You can use the N ratio or you can use the T ratio. N stands for number of revolution or rotations or rotational frequency. T stands for number of teeth, and VR is the velocity ratio, single gear compound. But we have with intermediate gear, I've already explained that when there's intermediate gear, its purpose is to change the direction of the driven gear. So the formula is that this gear is in mesh with this one. So it's NA TA equal to NCTC. NCTC is also equal to this one because it's driving gear B. So depending which side has givens and which side you're looking for the unknown, you equate those two sides. You don't equate all three formulas. It's either you choose NC and TP or A and C. We also have a compound gear drive. compound gear drive, it will be more than one driver. If you look at this one, there is one driver, it's called an intermediate, and this is a driven. Compound gear drive, or is gear train, it has more than one driver and it has more than one driven. Now, in this type of combination, the first driver, its shaft is the input shaft. And the last driven, the shaft that it is keyed or mounted on, is called an output shaft. Now, the formula for a compound gear drive, velocity ratio, even if it's a compound, is still the input, which is the effort. This is velocity ratio N of the driver. Divided, output will be the last one, which is the last driven. So if it's a compound, still velocity ratio is the input over output, but first driver over the last driven. If you want to calculate velocity ratio using the number of teeth, you multiply is the product of all the driven gears divided by the product of all the driver gears. So when we use the T, you don't only choose 2. If it's a compound, that means we have many gears that are connected. You will have to multiply all the number of teeth for the drivens divided by product of all the number of teeth for the driver gears. But when we are using the N, is still the first driver divided by the last driven, even if it is a compound. There is a velocity ratio, is N of the first driver divided by N of the last driven, input of the over the output. Let me show you how it is given, the formulas and exams. The formulas is NATA equal to NBTP. So you need to remember the gears are in mesh, you equate their velocities. So velocity is NA and TA. SV, we don't know a velocity as SV, but we know it as VR. It says NA, you know the letters of alphabet are A to Z. So A is the first one, and Z will be the last one. So this formula will be given. Let's look at the activity. It's taken from question paper of August 2016. In the gear system shown below, NA is 600 revolutions per minute. So this shaft and the gear that is mounted on it is rotating at 600 revolutions per minute. So when you're sketching gears, we don't sketch the 3D view like this one. Also, we cannot do the circles. We can just do the schematic diagram, which is this diagram. So this is the symbol for a shaft, and this is gear A. A has 75 teeth. NA is given, TA is also given. So sometimes they will say the input shaft. Remember, the input shaft is where the first gear is mounted on. So if you are given the rotation of the input shaft, it means the gear that is mounted on it will have the same rotation as the shaft. NB, gear B is this one that meshes with A. So this is how the gears that are in mesh are symbolized. So A is larger than B. They are in mesh. For B, you're given the rotational frequency, that is 1,800. So as you can see, gear B is smaller than gear A. So it has many revolutions compared as to A. As smallest gear has many or more rotation compared to the larger gear. Now, gear B also has a shaft. It's keyed or is mounted on this shaft, shaft B. On the same shaft as gear C. So since these two are keyed on the same shaft, they will rotate at the same speed because they will rotate together. So the N of B is the same as N of C. There is a relationship. Gear D meshes with C. Gear D meshes with C. So A, since A meshes with B, A is driving B. And because B and C are on the same shaft, they will rotate at the same time. And that will cause C to drive D because C meshes with D. So this is a compound gear because we have A that is driving B and C that is driving D. There are two drivers and there are two driven. B is driven by A and D is driven by C. So shaft A is the input shaft and shaft D is the output shaft. Now let's look at the calculation. It says calculate the number of teeth of gear B. Gear B meshes with A, so the formula that will be given in the exam only apply to the gears that are in mesh. We cannot use that formula between A and C because A is not in mesh with C. That formula, revolutions or velocity of A will be the same as velocity of B because they are in mesh. Now we can use a formula between A and B, NATA equal to NBTB. The formula will be NATA equal to NBTB. Let's look at the givens with what is given. NA is 600 and TA is 75. NB is 1,800. So substitution where there is NA, it is 600 multiply TA is 75 equal to NB is 1,600. You can always write down the givens first so that you know what you're looking for. This is multiplied by TB. So if both ends are in revolution per minute, even this revolution per minute would cancel out this one. So you cannot work with the revolution per minute and revolution per second. They must be both of the same unit. Then we use a calculator, 600 multiplied by 75. This will be 4,445,000 equal to 1,600 TP. Divide both sides by 1,600. Both sides by 1,600 cancels out. The number of teeth for gear B will be 45,000 divided by 1,600. This will be 28.1. But we cannot have 28.1 teeth. We can round off this number. We can round off. We cannot have 28.1. And in case of design, we always round up. Since it's comma 1, we're going to say this will be equal to 29 teeth. So you were given 600 multiplied by 75, which has 450,000. And gear A It's 1,800, sorry. NP is 1,800. Let me fix that. This is 1,800, 1,800 divided by 1,800 both sides. Divided by 1,800. So it's 25. The answer for TP is 25 teeth. So NP was given as 1,800. Let's look at the second question. It says calculate the rotational frequency of gear D in revolutions per minute. So D measures with C. So it has a relationship with C. The formula will be NC/TC equal to ND/TD. You always use the gears that are in mesh. So the relationship between C and B is that since they rotate in the same shaft, NC will also be 1,800. So where there is NC, we're going to put 1,800. And TC is given as 45. So the substitution will be like this. 1,800 multiplied by 45 equal to, it says calculate ND. So ND is the unknown. Multiplied by, let's check if the value of TD is given. TD is 20. So where there is TD, we're going to put 20. So for as long as this is a revolution per minute, this will also be revolution per minute. Divide both sides by 20. Divide both sides by 20, cancels out. ND will be equal to 1,800 multiplied by 45 divided by 20. ND is 4,050 revolutions per minute, or RPM. So it is 1,800. Let me just check the calculator. Multiply by 45 divided by 20. Yes. Now let's look at the picture. If it makes sense, D is the smallest gear, so it will have more revolution compared to the rest of the gears. So it makes sense. From here to here is smaller than this one, also smaller than this, smaller than this. You always use the gears that are in mesh to apply a relationship. You don't have to remember a formula for a compound gear, but we can also use it. We can get ND using the compound because NA divided by ND is equal to product of the driven. So it will be TB multiplied by TD divided by product of the driver, which will be TA divided by TC. So that formula can give you the same answer. The one of compound that says driver divided by driven, which is A over Z, is equal to TB, product of the driven teeth, divided by TD, these are the driven, divided by TA multiplied by TC. So this will give you the same answer when you make NP the subject. But you don't have to use this complicated formula. Just remember to equate the gears that are in mesh. And remember, if gears are keyed on the same or are mounted on the same shaft, they have the same rotational frequency. Thank you.